The key areas of Army interest were static and dynamic pressures produced by detonations of various yields, and especially study of the long positive phase resulting from both air and ground bursts in the megaton range. We collected data also on the rapid determination of fallout. Here we are interested because of the proximity of friendly installations to targets on the atomic battlefield. Such data is, incidentally, completely dependent upon timely and accurate weather information. To protect our stockpile of tactical atomic warheads, as well as to impair or destroy the enemies, the Army required knowledge of the vulnerability of nuclear weapons. One other key factor in our support of atomic strikes is definite knowledge of the yield and ground zero of our weapons. Red Wing experiments dealing with the detection, location, and analysis of atomic bursts were successful. This will lead to the development of portable, self-contained instruments capable of continuous surveillance of the atomic battlefield.
The results of Red Wing were of considerable interest and benefit to the Navy. An outstanding feature was the increased yields obtainable from devices of greatly decreased sizes and weights. Such factors will permit diversification of delivery systems in aircraft and ships. Our first-line carrier aircraft, the A-3D, or Sky Warrior, was exposed to blast and thermal effects from megaton yield weapons. It was also positioned to simulate a drop aircraft, and these tests indicated that the A-3D can deliver megaton weapons with a good escape probability. In the field of atomic defense, progress was also made. All ships of the Navy Task Group were equipped with washdown systems which proved to be most effective. Preliminary data gathered from specially configured remote control ships in the fallout area provided additional information regarding decontamination procedures in general. Data to determine the relative radiation dosages from the air, water, and the ship's weather surfaces was also collected. This knowledge provides additional criteria in the development of ship's shielding. Also, experiments with types of protective coating were conducted on ships and certain test aircraft. Spraying of a paint-like substance on exposed surfaces added a high degree of protection against contamination. The results of these experiments will assist us in the determination of naval operations in heavy fallout areas, as well as provide valuable data for the design of naval vessels of the future. The Navy is also interested in the many aspects of the various weapons effect tests as they pertain to aircraft, which will be discussed by General Griffith. Throughout the operation, the necessity for fast and accurate weather predictions was demonstrated. The Navy will benefit from the development of the WASP, a high-altitude wind-sounding rocket, and by the increase of altitude of weather balloons. These two developments will provide faster and more accurate weather data from altitudes of 60,000 to 100,000 feet. In addition, the regular Navy window shells prove most valuable for soundings up to 34,000 feet. All this will lead to an increased effectiveness of fleet operations in the conduct of atomic warfare. In conclusion, the 6,000 naval personnel gained valuable experience, as they are much better prepared to cope with the many aspects of atomic warfare and will form a nucleus to instruct other naval personnel.
The scope of Air Force operations in Red Wing precludes a discussion of the results of each program in which we had a vital interest. In view of this, I have selected and shall briefly summarize only two which I consider most pertinent to this presentation: the Aircraft Effects Program and the Early Penetration Project. The Aircraft Effects Program was designed to test the structural responses of operational type aircraft to the blast and thermal loads experienced in the vicinity of nuclear or thermonuclear detonations. The particular Air Force aircraft tested during wing were the B-52, the B-47, the B-66, the B-57, the F-84F, and the F-101. These aircraft were positioned to receive the type loads they would experience during weapon delivery. In general, they were flown directly over ground zero at a time shortly before, at, or after the burst time to receive the desired effects. While the objective of such studies was the collection of scientific data, the safety of air crews was a consideration of primary importance in the conduct of Red Wing aircraft tests. Elaborate precautions were taken to ensure that the aircraft would be in the right place at the right time. The preliminary data acquired by the effects aircraft indicate excellent results. In addition to giving us safety parameters for existing aircraft, the data should be of great value in design of future aircraft. The Early Penetration Project was included to investigate the feasibility of aircraft penetrating clouds from high-yield weapons at times shortly after a burst. 5 B-57s and 21 pilots from the Tactical Air Command were assigned for the project. The B-57B was chosen due to its high-altitude capabilities, and the 21 pilots were required to ensure that sufficient data could be accumulated without subjecting any individual to excessive doses of radiation. It was determined that such cloud penetrations would have to be made so early that the conservative operational radiation dosage limit of 3.9 Roentgen would have to be exceeded in individual penetrations. Task Force 7 received approval for a dosage of 50 Roentgens for the 21 pilots. Mission planning, however, assured that no pilot would receive over 25 Roentgens, and in a great many penetrations, no dosages over 10 Roentgens were recorded. During the operation, there were 2 drops by aircraft. This was a free-fall drop of a thermonuclear weapon by a B-52 flying at 40,000 feet. It was set to burst at 5,000 feet, but actually burst at 4,300 feet with a yield of 3.5 megatons. The bomb did not have a good CEP because of personnel error. This caused some loss of data. Most significant, however, is the fact that we satisfactorily proof-tested the delivery capability of a thermonuclear weapon with a B-52. It can be predicted that high-performance operational type aircraft can fly through the cloud from any weapon, the design of which we know, at an altitude of 45,000 feet or less, at any time later than 10 minutes after detonation, and the pilot will probably receive no more than 75 Roentgens total dosage.
Thank you, General Griffith. Admiral Sutherland, will you please summarize the operation at this time?
Technically, operationally, and militarily, Red Wing may be summarized in one word: success. This operation marks a most significant step forward in the research and development of fission and fusion weapons. These successful tests will lead to the development of a variety of weapons calculated to meet a wide range of military usage, including defense against air attack. This variety of weapons will permit diversification of delivery systems of all kinds, that is, aircraft, missiles, gun-fired projectiles, demolitions, and depth charges. The emphasis on safety of task force personnel, of the Marshallese population, of transient aircraft, and shipping paid off 100%. Most important in the safety program was the ability to predict and hence predetermine radioactive fallout. The key to this was greatly improved weather forecasting stemming from increased knowledge of tropical meteorology. In carrying out the Red Wing test series to its successful conclusion, one factor, a most gratifying factor, is quite evident. The three military services, a large group of scientists, technicians, and contractor personnel worked and lived together for many months in the Central Pacific, far from home and under trying conditions, to get a job done. This job was accomplished, and the many benefits are already being put to practical use. This concludes Admiral Hanlon's film report of Operation Red Wing.